Assalamu alaikum, welcome to the Dynamic Engineers. So today I'm here with one other concept, that is the long column and short column. We'll be talking about the differences between long column and short column. Generally, if you look at a long column and a short column, you cannot just say that whether it is a long column or whether it is a short column. But to differentiate between long columns and short columns, we will have to go through some of the properties or some of the mathematical calculations. By a general look, if the length or the height of a column is very much greater than its width, it can be a long column. But this is the only or just a general guess. The other mathematical calculations include the effective length and the width of columns. So the property number first that I'll be talking about is the effective length to its width ratio. Okay, so if the ratio of effective length to its least dimension is greater than 12, it is a long column. Like how? Effective length, I will call it LE, divided by least dimension of the column. Okay, any dimension, let me explain it. Least dimension means DL is greater than 12, then it is a long column. While if LE divided by DL is less than 12, it is a short column. So what is effective length and what does least dimension means? Let's see this. This is a column having dimension of 900 millimeter by 750 millimeter. This is just for explanation process, and its height is 15 meter, and this is the effective height, that is 15 meter. Okay, so here if you look at this, the least dimension in both these, the least dimension is 750 millimeter. So we will be considering here in this least dimension 750 millimeter. Okay, and this is the effective height, that is the 15 meter. So if 15 meter divided by 750 millimeter is greater than 12, then it is a long column. While and vice versa, if the effective length to the least dimension ratio is less than 12, then it is a short column. This is the first criteria, and this is the first mathematical calculation. If you look at any column, you can just say that whether it is a long column or whether it is a short column by just going through this mathematical calculation. This is the first criteria. The second criteria is about slenderness ratio. Okay, so slenderness ratio, second property is SR. I will call it SR, the slenderness ratio. Okay, so if the slenderness ratio of any column is greater than 45, then it is a long column. While if slenderness ratio is less than 45, then it is a short column. This is the second criteria and the most important criteria. Both of these criteria are important mathematical calculation through which you can differentiate between long column and short column. The third important criteria that is considered during designing process actually, that long column will always fail in buckling, while the short columns will fail in crushing. So what is buckling? Just if you look at this column, whenever vertical load is applied over this column may try to buckle out like this. This is what we call the buckling phenomena. So long column always fail in buckling, while short columns, this always fail in compression. Like somewhere like this or like this or like this. Okay, so all these failures are compression failures, while this is the buckling failure. So these are the three main differences between long column and short column. The last one, that is the failure mechanism, is considered during design process, while the other two are considered during just having a look at any column and by simply calculating their effective length and least dimension and calculating their slenderness ratio. So I hope you would have learned something from this video, and if you have learned something, don't forget to subscribe our channel. For sure we will be bringing some other videos, important videos for you people. Thank you very much.